Good morning, everybody. Welcome to Friday. Happy Friday to you. I will apologize in advance for the length of this video. It's going to be a little bit longer, maybe double, maybe about 10 minutes of what my normal ones are. But there's a couple of things that I need to make sure I point out to with you on these three problems here. There's a third one down there before I turn you loose on your homework. So we're going to take our factoring and finding roots and using division to the next level today. So you'll notice the directions here say factor each and find all of the roots. Remember, this is the fourth degree polynomial, so there's potentially four different roots that will occur within this equation. One of the roots has been given to you. So in order to find the roots, if we're given one especially, we're going to use our synthetic division. So we know one of the roots is 3, so I have 1 for the x to the fourth, 1 for the x to the third, minus 10 for the x squared, to my positive 2, and my negative 24. And when I do my division out here, remember, drop the 1 down, multiply 3 times 1, that's 3. Add them together is 4. 3 times 4 is 12. Write it down. Add those together, that's positive 2. 3 times 2 is 6. Add those together, and we get 8. 3 times 8 is 24, and you'll notice that we end up with a 0 there. So that's a perfect root. So we have that. Now, keep in mind, because when we find this, this becomes x to the third plus 4x squared plus 2x plus 8 is now our new equation. So we have this root of 3 here that was given. Now, we're going to want to do synthetic division. So let me back up a little. If we're talking about factoring, this is now, whoops, that should be a minus 3 because it's the opposite, what this looks like. Okay, so this is eventually, we're going to factor this all down. Now, here's where it gets a little interesting. We're going to take a 1, the 4, the 2, and the 8 here, and we're going to apply synthetic division. But you have to figure out what values to put in. And the values you put here for roots, the potential values are going to come from this number right here. So for the factors of 8, so you have plus or minus 2, you have plus or minus 8, you have plus or minus 1, although that won't do anything for you, and you have plus or minus 4. All of those are potential roots. So now here's where your mental math skills have been building up. That you want to figure out and try some of these different numbers. So for instance, I think I'm going to try, since these are all positives, I'm going to try negative 2 to start. And so I try my synthetic division. That's negative 2, that's 2, that's negative 4, that's negative 2, and that's a positive 4. And you'll notice I end up with a 12 there as my last number. That means negative 2 is not a root. So by process of elimination, I'm ruling out 2. I'm also going to rule out positive 2, since positive 2 is all just going to keep growing and growing because there's no negative numbers. So I'm going to lean towards, I know once again, I'm going to need 4 and 2, 1 and 4 and 2 and 8. I'm going to go with negative 4 this time. The reason I'm trying negative 4 is, again, I have all positive values here. So I put in negative 4, and this is just guess and check. Once again, these numbers all come from this positive 8. So I write down 1, I have negative 4, that's 0. That's 0, that's positive 2, and that's going to be negative 8, and there's my 0. So my one root is 3, my second root is 4, and when I rewrite this, you'll notice I end up with x squared, because I drop it from 1, there it is originally, and I have 0, and then I do a plus 2 here. Well, x squared plus 2 is as factored as that's going to get. So my factored form, I can't do this. If this was an x plus 2x plus 6, I could maybe factor it or apply the synthetic, or imply completing the square, a quadratic formula. So our factored form that we're going to write down first is going to be our x plus 3, our, oops, I did it again, x minus 3 that I had up here, x minus 3, x plus 4, and then x squared plus 2, and that equals 0. So here's my original equation. Here's the factored form of that equation. The roots, which is the other part, we have positive 3, we have negative 4, and when you add over you do x squared plus 2 equals 0, I get x squared equals negative 2, so I get plus or minus I square root of 2. So I have two imaginary roots. So 4 roots altogether, real 3, real negative 4, and imaginary 2 imaginary roots at the square root of 2i. Now, a couple of things I need to point out to you when you go to do these. One, you'll notice in their second example here, I've got x to the fourth, x to the third, and then it skips down to x to the first. So keep in mind, we're going to have to add in here a 0x squared. When you do synthetic division, if you have 4, you have to have 5 numbers. So my numbers would be 1, 5, 0, 27, 135. And I know one of my roots is negative 5. So I have 1, I have negative 5, I have 0, 0, 0, 27, negative 135, and that's 0. Okay? So factored form right now I have x plus 5, and I have x to the third, that's going to be 1 less, plus 27 equals 0. Now, here's where things get a little interesting. If you think back to factoring, when we were doing our factoring earlier in the year, I have a perfect cube here, and I have a perfect cube here. So we can factor this using the idea of the cube root of x, the cube root of x cubed is x, plus the cube root of 27 is 3. And then I square this number, x squared, plus, that's going to be minus 3x. And that's going to be plus 9 when we square that. And this is taking the factoring, basically, a perfect cube. Okay? So, last thing. If I do a couple of checks, I'll notice that 3 times 3, I can't factor this anymore. So this is my factored form. I am done here because I cannot easily factor this anymore. So that's the factored form. And then I have roots that I have to list. And my roots starts out with I have a negative 5. I have right here a negative 3. And then we have to find the roots from this. I'm always partial to completing the square, or solving by completing the square. So you can do that. X squared minus 3x equals negative 9. So that tells you it's going to be an imaginary number. Okay, and you know how to x minus 3 halves, and then you square it, and plus 9 fourths, plus 9 fourths. And I'm going to stop there. You can finish this up on your own. You'll notice it's going to be negative. So we have an imaginary root. If you were to work on that one for a second, it would come up to be 3 plus or minus 3i squared of 3 all over 2. Okay, so if you finish completing the square, I don't want to waste your time doing that, but I want to point out one last thing down here. These are all things to think about when you're doing your homework. If you look at our last example here, I've got x to the fifth, x to the fourth, x to the third, x squared, and x. So my first thing that I notice here is I don't have that number without an x, so my first order of business is going to be to factor out an x to make it x to the fourth plus 4x to the third minus 10x squared minus 20x plus 25. And that equals 0. Now, once again, you are given one of the roots, so now you can go to your synthetic division. 1, 4, negative 10, negative 20, and positive 25. And you can do the same thing you did up at the problem above to get your factored form when you get there and to get your roots. Now keep in mind, once again, x to the fifth is a fifth degree polynomial, which means you're going to end up with 5 roots when you're all done. Notice again here, fourth root polynomial, you have 4 roots. The plus or minus gives you 2 here, 1 here, 1 here. To the fourth, you have 2 roots, 2 imaginary, your plus or minus here, and then you have -4 and +3. Okay, I'm not going to finish that out. If you have any questions, I think you could pick it up from here to finish number 3. You finish up doing what you did in number 1. So if you have questions, try a couple of these. If you still have questions, jump into office hours. They'll be at the usual time today, and I'll be there ready to answer whatever you have. Okay, hope all is well and everybody's healthy, and we'll talk to you guys soon.